For the marine natural resources topic that debaters are considering, one big aspect of that is the oil and gas resources off the coast or other energy sources like tidal energy or wave energy. But the main energy resource off the coastlines, is oil and gas. And what I wanted to do is give sort of a background presentation on energy economics for students to be able to put the energy policy issue in perspective. This is a picture of Friedrich Hayek, the author of a great essay called The Use of Knowledge in Society. And I happened to be at this meeting with Hayek at the Institute for Humane Studies. John Blundell took the pictures there. And Hayek was at this gathering talking about living in Vienna and so forth. But his book on the use of knowledge in society argued that the price system is key for understanding how a market system works and for mobilizing knowledge, mobilizing dispersed information. The relevance for the offshore energy topic is that no one can really know which energy resources are most valuable or whether we should be developing more wind energy or wave energy or oil and gas off the coast. To discover this, we need a process, a searching process where people can communicate this information. So a couple examples for how the energy system works through prices. Consider that when the hurricane hit in 2005, Hurricane Katrina, it wiped out a significant amount of the U.S. refining capacity. And the question is, what should the response be? The government could have stepped in with mandatory limits on who could buy how much gasoline or priorities for coupons for people most important to get it and have a system like that. But instead, with the government not doing anything, what we had was a spontaneous order response that was a coordinated response by millions and millions of Americans who altered their behavior within hours of the end of the hurricane and the settling down. And as soon as it was clear that a massive amount of our refined capacity was taken offline, refining capacity was taken offline, and a shortage of oil, how did the market respond? Well, the price goes up. The price goes way up. $3 a gallon, $5 a gallon. By allowing prices to clear on their own, it of course disadvantages poor people, makes it hard for them. Surely it does. But what it does is lets people decide who really needs to use gasoline. So teenagers didn't drive as much. People that felt they could carpool or felt they could put off trips, felt they could drive less, they made those decisions. Rich people, of course, could buy as much gas as they want and waste it, although it's not clear what incentives they have to do that. But in general, by allowing millions of people to respond, we were able to mobilize the knowledge that only people have about how important gasoline is for them. And prices are what do this. At the same time, the higher prices encouraged a tremendous response on the part of other refiners and people shipping in gasoline from other locations, trying to chase those higher prices down. So this system is, again, the spontaneous order system. People with big SUVs drove less. People that had two cars drove the one that worked better, got better mileage. I remember traveling the country in those days and renting cars. And every time I rented the cheapest car I could, I'd end up with an SUV because most people didn't want to rent SUVs because the gas was too expensive. I didn't figure that out the first time and thought I was getting a great deal and ended up paying, $80 for gas. So the responses, now the rental car companies can respond quickly, right? They rent their high mileage fleet and their low mileage fleet doesn't rent. But that's a quick response that prices change behavior. 200 million cars, a lot of people didn't fill up their gas tanks when the price went up. So people that would normally buy a full tank of gas bought 3 gallons of gas when the price unexpectedly went from $2.50 to $5. What that meant is people were drawing down the gas they had, not filling their tanks, and that allowed also for economizing in the short term as new refining capacity came online. So again, just some examples there on prices handling disaster responses quickly. A second way of looking at the oil and gas industry is to first realize that oil and gas development has been one of incredible efficiency. we have gone over centuries to always to cleaner burning natural resources, cleaner burning fuel. So people originally burnt wood for fire, for heat, and for cooking. Lots of smoke and pollution from that. Then go to peat, like you dig out of the ground. It works for heat, but it's again smoky. Coal, which is much cleaner than peat, but not as clean as oil than to gas. We've gone step by step to cleaner versions of a fuel for heating and for power. And that's what we can expect to continue to happen. Natural gas, where we are now, thanks to the huge increase in the shale gas development, much cleaner than oil, much cleaner than coal, and providing a larger percentage of U.S. energy. And we don't know what's next. Might be pure diesel made from natural gas, or might be a wind or solar technology that we use more of. Might be algae fuel if it works. But we can expect cleaner fuels to come from the technology. The first oil crisis, this comes up in the marine natural resources topic, the first oil crisis was the oil crisis from whales, right? As whale technology for harpooning whales increased, we basically dramatically lowered the population of oil from whales. The price went up rapidly. As the price goes up, people hunted oils more intensively, but also people began to say, what's a substitute for oil? And they'd found fuels bubbling up out of the ground in salt marshes. And there was an effort on the part of chemists to figure out how to turn this crude out of the ground into kerosene that could be used for light, which is what whale oil was used for. So in a sense, the oil industry itself was a response to an oil crisis, the whale oil crisis. The next oil crisis, John D. Rockefeller developing oil in Pennsylvania, at some point the oil was running out in Pennsylvania. There was oil in Ohio, but it was full of sulfur. It wasn't oil that could be used. Rockefeller basically told his board that he wanted to hire, hundreds of chemists and expand into oil drilling in Ohio, even though they didn't know if they could make the oil converted into kerosene. His board was hesitant. Rockefeller basically bet the company on this. He told the board that he would buy the oil himself if the board didn't approve it. They finally approved it. And the scientists, the chemists, figured out how to turn this different hydrocarbon combination in Ohio into fuel, and later Standard was able to develop markets for the byproducts of kerosene like gasoline. But what's interesting is we've run out of oil over and over and over through the past because we didn't have the technology to turn the hydrocarbons that were left into usable fuels. The same actually through the 1990s with the tar sands in Canada. People have known for decades, for centuries, about the tar mixed with sand, but there was no technology to turn it to fuel at marketable prices. So experimenting, millions of dollars, hundreds of millions invested, and finally they figure a way to cook it down so that at market prices of $50, $60 a barrel, they could convert Canadian tar sands into fuel. Again, though, there's no such thing as natural resources. Resources are just gunk bubbling up out of the ground, rocks. It's only when the technology is developed to refine fuels into usable fuels, to hydrocarbons into fuels, to turn the tar sands into gasoline. Only when the technology develops do these raw materials actually become natural resources. This is the same more recently with the shale oil. Only when the horizontal drilling technology was developed and the fracking, hydraulic fracturing process was developed to extract the shale gas and shale oil, only then did that resource become a natural resource, become a useful, valuable product. So in each step of the way, it's the technology that makes these materials valuable. And this is very much the case with the raw materials or the natural resources or the hydrocarbons off the coast, the shale and gas that people are drilling for off the coast, the Davy Jones deep drilling that's going on off Louisiana coast by Freeport McMoran. Okay, so opportunities for innovation. There's also in oil and gas sort of a source of instability, and that is that most of the oil and gas reserves around the world are owned by the government. Unusually in the United States, private landowners own land in Texas and many parts of the country. The government owns land off the coast and has so far only allowed drilling in the Gulf Coast, the Gulf Coast toward Texas, leasing oil lands for exploration in the eastern Gulf Coast next to Florida has been more politically charged, or off the Atlantic or off the Pacific. There's huge amounts of oil and gas in these areas, but politically, the state governments haven't allowed it to be drilled in most places. And this has to do with the history of the Santa Barbara oil spill, which shut down oil and gas drilling off the coast of California. Okay, here's a map of the country. And in a sense, the colored areas are the lands with the most oil, gas, and shale energy reserves. Now, what the map actually is a map of federal and Indian lands. There's, of course, plenty of oil and gas or shale oil in Pennsylvania and Texas and in North Dakota. But there's also huge amounts in Colorado and massive amounts in California and elsewhere. But the federal government generally doesn't allow it to even be explored, much less drilled. What's interesting about the map, too, is this shows the changing political philosophy on the part of the federal government. From the founding of the country through the late 1800s, it was generally believed that the government would have ownership of land only when a new territory became a state, but would be steadily selling the land to private owners, because the view was the federal government wasn't an agency to own land. The government ownership of land wasn't part of the founders' view. However, those views changed in the progressive era in the late 1800s, early 1900s with Teddy Roosevelt and others, who basically lost their faith that the private sector could manage scarce resources well, like timberland, forest land, wilderness areas, and the coastlines, which then began to be managed by the state and federal government. So usually the state governments own to 3 miles out, and then the federal government owns the rest of the way out to the, 200 or 300 mile line. Here is a map of the oil and gas operations in the Gulf of Mexico. This is off the coast of Texas, Louisiana, and Mississippi. And you can see the vast amount of pipelines, drilling, and land areas there. And one question is, why is it only there and not someplace else? Well, they've only allowed it here. And you could argue when you're debating this topic that other areas should be developed as well. This is a maps of both Texas and Alaska, and you can see in Texas there's resource-rich area like Alaska. The government-owned lands are only tiny bits here and there of Forest Service wilderness areas and a Department of Defense area. That's because Texas came into the Union as an independent country, and so its land wasn't turned over to the federal government. Instead, it was all state. So there's very little federal land. There's Big Bend National Park down at the bend, sticks into Mexico, but most of Texas is private. In Alaska, however, most of the land is owned by the government. And if you look at a close-up map of Alaska, private land is like 1% of the total land area. The rest is national forests, national parks, wilderness areas, Bureau of Land Management areas, some state government, state-owned land is blue. So a massive federally owned resource, at least along the coastal areas for this topic, the marine areas, the affirmative could argue that those should be managed differently to allow natural resource development, as well as to allow improvement of the management of Alaska fisheries. Here is the website of the Bureau of Ocean Energy Management. After the scandal where it turned out the federal agency handling energy leasing was in bed with the private sector developers, figuratively and apparently literally, they split the agency into an environmental side and to an ocean management energy side. And this is the organization that's trying to do national ocean policy, environmental stewardship, and dealing with resources from the ocean. So this is the federal government control that the affirmative could call to be managed differently as an affirmative. So they're trying to manage the exploration and development of offshore oil and gas, But of course, mostly what they're doing is not allowing the exploration and development of offshore oil and gas, because that's the political preference of uh, the special interests that lobby this group, the environmental groups, the supporters of the administration. You could, though, argue that the private sector, the energy industry, also lobbies heavily and would have influence in this organization. Here's a map, though. If you go to their website, they're saying, yeah, we're excited about developing energy resources off the coast that they manage. And here is a chart that shows the activities that they're working on in Washington, Oregon, California, Hawaii, and then all up and down the East Coast. But what are they working on? They're promoting wind energy. They're promoting the kind of energy that is politically appealing, like putting offshore windmills that the view is generate energy. However, when you look into that, you'll find that incredibly cost prohibitive, expensive, uh, not friendly to the environment. The disaster that's happening in England with the rapid decline of their wind energy technology, that is where the failure rate is much higher, the energy production rate is much lower. So in most cases, wind energy tends not to be cost effective or environmentally friendly, but again, that's debatable. So I've just asserted those claims. You can go in and join the debate. And for people that are proposing wind energy off the coast, there's arguments to look at there. I recommend the book Energy, the Master Resource by Rob Bradley, and also the Peter Huber and Mark Mills book, The Bottomless Well, that looks at the sort of the vast supply of energy we can expect in the future from a variety of sources, both hydrocarbon and alternative energy. Just to give you sort of a background for energy costs, people think of the price of gasoline going up. Well, it has in some sense, but if measured in terms of hours worked, that is how long you work to be able to afford a certain unit of energy, the average laborer now, according to this, can buy a week's worth of gasoline for about 90 minutes of work, but that same amount of energy cost a full workday in the 1920s. So the energy that we buy to drive our cars is much cheaper for us in terms of time worked. That's because we're so much more productive with our work. We create value so much better than we did in the 1920s, or our grandparents did. And because energy costs have fallen dramatically over time as refining capability has improved to make less expensive gasoline measured in gold or measured in hours worked. Similarly, electricity costs have dropped dramatically. You can look at the numbers. The number of minutes you have to work for a kilowatt hour have dropped from 8 minutes in 1920 to 0.2 minutes in 2000. So again, the technology is making energy much cheaper for us in this country. Another interesting chart is the people concerned about running out of energy. This is a graph that shows it's not a graph, it's a bar graph. Proved and provable and probable resources. That is, how much coal do we know we have in the ground, and how much coal do we think we have? Same with natural gas. How much do we have? How much do we think we have? This is from 2002. And what we find is we've got some 230 years of consumption, current consumption of coal that we know exists. But we expect to have almost 2,000 years in total, over 2,000 years of coal at current consumption. If our consumption goes up, it'll be less, but it's still a long time. Natural gas, 65 years of proved reserve and 61 years of probable resources. Now, this is from 2002. What's changed? Well, in 2005, 2006, 2007, all of a sudden a shale gas comes online and massive development. So this, if you look at the current data, 2012 data, for proved natural gas and probable natural gas, you'll find it's dramatically more. And I don't know the numbers right now, but you'll find it's gone up significantly. The same with crude oil. We have a lot more crude oil now than we did before. This had it 50 years proved, another 70 years probable, but that's before shale oil and a lot of the new deep sea finds were discovered off Africa and off Latin America off Brazil. Another interesting chart is the world crude oil. In 1944, they had 51 years of proven reserves. That is, or I'm sorry, 51 billion barrels worldwide of proved reserves. Then they consumed 18 times more than that until 2003. And at the end of consuming 18 times more, they had basically 900 billion more barrels in reserve. So what that means is technology is discovering oil far faster than we're using it. By 2003, the reserves are 25 times what the reserves were in 1944, even though we've consumed vastly more oil than we ever thought we have. And why is this? Because drilling technology, exploration technology, computer technology has advanced rapidly in this time to make oil more plentiful in the earth than it was before. That is, because we can find it and get to it and bring it out economically, we have more, real reserves than we had 80 years ago. Another chart looking at world natural gas, it's the same sort of story. Natural gas reserves are way up, and this is before the shale was discovered, so the number's even more now. And this is a final chart on this, estimated global supplies, 40 years of crude oil, 70 years of crude oil resources, 115 years when you add the tar sands and heavy oil. But when you add shale oil, and this is what's in Venezuela, what's in Colorado, it's up to 450 years or 2,000 years of these oils that we can get out of the ground, not economically now because we don't know quite how to do it, but it's there. And of course, agricultural oils are inexhaustible because that's converted from the sun. Okay, next I'll have a presentation on looking at public relations campaigns by Chevron and others.